Hello everyone, welcome to today's session. Let's move ahead to one of the most important topics in statistical inferences, which is hypothesis testing. So basically, statisticians use hypothesis testing to formally check whether the hypothesis is accepted or rejected. Hypothesis testing is an inferential statistical technique used to determine whether there is enough evidence in a data sample to infer that a certain condition holds true for an entire population. So, to understand the characteristics of a general population, we take a random sample and we analyze the properties of the sample. We test whether or not the identified conclusion represent the population accurately, and finally we interpret the results. Now, whether or not to accept the hypothesis depends upon the percentage value that we get from the hypothesis. So, to better understand this, let's take a small example. Before that, there are a few steps that are followed in hypothesis testing. You begin by starting the null and the alternative hypothesis. I'll tell you what exactly these terms are, and then you formulate an analysis plan. After that, you analyze the sample data and finally you can interpret the results. Now, to understand the entire hypothesis testing, we'll look at a good example. Now consider boys Andrew, John, Nick and Daniel. These boys were caught bunking a class and they were asked to stay back at school and clean the classroom as a punishment. So what Nick did is, he decided that 4 of them would take turns to clean their classrooms. He came up with a plan of writing each of their names on sheets and putting them in a bowl. Now every day they had to pick up a name from the bowl and that person had to play in the class. That sounds pretty fair enough. Now it has been 3 days and everybody's name has come up except Nick's. Assuming that this event is completely random and free of bias, what is the probability of Nick not cheating? Or is the probability that he is not cheating? Actually, this can solve by using hypothesis testing. So begin by calculating the probability of Nick not being picked for a day. So we are going to assume that the event is free of bias. So we need to find out the probability of Nick not cheating. First, we will find the probability that Nick not picked for a day. We get 3 out of 4, which is 75%. 75% is fairly high. So if Nick is not picked for 3 days in a row, the probability will drop down to approximately 42%. So 3 days in a row, meaning that the probability drops down to 42%. Now let's consider a situation where Nick is not picked up for 12 days in a row. The probability drops down to 3.2%. That's the probability of Nick cheating becomes fairly high. So in order for statisticians to come to a conclusion, they define what is known as a threshold value. Considering the above situation, if the threshold value is set to 5%, it would indicate that if the probability lies below 5%, then Nick is cheating his way out of detention. But if the probability is about threshold value, then Nick is just lucky and his name isn't getting picked. So the probability hypothesis testing gives rise to 2 important components of hypothesis testing, which is null hypothesis and alternative hypothesis. Hypothesis is based on approving the assumption. Alternate hypothesis is when your result disapproves of the assumption. Therefore, in our example, if the probability of an event occurring is less than 5%, which is then the event is biased. Hence, it proves the alternate hypothesis. So guys, with this, we come to the end of this topic. Let's go ahead and understand what exactly is supervised learning. So supervised learning is where you have the input variable x and the output variable y and use an algorithm to learn the mapping function from the input to the output, as I mentioned earlier. Example of face detection. So it is called supervised learning because the process of an algorithm learning from the training data set can be thought of as a teacher supervise the learning process. So if we have a look at a supervised learning steps, or what would rather say the workflow. So the model is used, as you can see here. We have the historic data, then again we have the random sampling. We split the data into training data set and the testing data set. Using the training data set, we, with the help of machine learning, which is supervised machine learning, we create a statistical model. Then after, we have a model which is being generated with the help of the training data set. What we do is use the testing data set for production and testing. What we do is get the output, and finally we have the model validation outcome. That was the training and testing. So if we look at a prediction part of any particular supervised learning algorithm, so the model is used for operating the outcome of a new data set. So whenever performance of a model degrades, the model is retrained, or if there are any performance issues, the model is retrained with the help of the new data. Now, when we talk about supervisors, there is not just one but quite a few algorithms here. So we have linear regression, logistic regression, and decision trees. We have random forest, we have classifiers. So linear regression is used to estimate real values. For example, the cost of houses, the number of calls, the total sales based on a continuous variables. So that is what linear regression is. Now then we talk about logistical regression, which is used to estimate discrete values. For example, which are binary values like 0 and 1, yes or no, true or false, based on the given set of independent variables. So for example, when you are talking about something like the chances of winning, or if you talk about winning, which can be either true or false. If it will rain today, it can be the yes or no. So it cannot be like when the output of a particular algorithm or the particular question is either yes, no, or binary. Then only we have a logistical regression. Next, we have decision trees. So now these are used for classification problems. It works for both categorical and continuous dependent variables. And if we talk about random forest, so random forest is an M symbol of a decision tree. It gives better prediction accuracy than decision trees. So that is another type of supervised learning algorithm. And finally, we have a naive-Bayes classifier. So it was a classification technique based on the Bayes theorem with an assumption of independence between predictors. A linear regression is one of the easiest algorithms in machine learning. It is a statistical model that attempts to show the relationship between two variables with a linear regression. But before we drill down to a linear regression algorithm in depth, I'll give you a quick overview of today's agenda. So, we'll start a session with a quick overview of what is regression, as linear regression is one of a type of regression algorithm. Once we learn about regression, its use case, the various types of it, next we'll learn about the algorithm from scratch. Each where I'll teach you its mathematical implementation first. Then we'll drill down to the coding part and implement linear regression using Python. And we will deal with a linear regression algorithm using least square method. Check its goodness of fit or how close the data is to the fitted regression line using the R-square method. And then finally what we'll do is optimize it using the gradient descent method. In the last part of the coding session, I'll teach you the implement linear regression using Python, and the coding session would be divided into two parts. The first part would consist of linear regression using Python from scratch, where you will use the mathematical algorithm that you have learned in the session. And in the next part of coding session, we'll be using scikit-learn for direct implementation of linear regression. So let's begin our session with what is regression. Well, regression analysis is a form of predictive modeling technique which investigates the relationship between a dependent and independent variable. A regression analysis involves graphing a line over a set of data points that most closely fits the overall shape of the data, or regression shows the changes in a dependent variable on the y-axis to the changes in a explanatory variable on the x-axis. Now you would ask, what are the uses of regression? Well, there are major three uses of regression analysis. For first being determining the strength of predictors. The regression might be used to identify the strength of the effect that our independent variable have on the dependent variable. For example, you can ask a question like, what is the strength of the relationship between sales and marketing spending, or what is the relationship between age and income? Second is forecasting an effect. In this, the regression can be used to forecast effects or impact of changes. That is, the regression analysis help us to understand how much the dependent variable changes with the change, and one of the most or more independent variable. For example, you can ask questions like how much additions say land will come for each $1,000 spent on marketing. Third is trend forecasting. In this, the regression analysis predicts trends and future values. The regression analysis can be used to get point estimates. In this, you can ask questions like what will be the price of Bitcoin in the next 6 months. So the next topic is linear versus logistical regression. By now, I hope that you know what is regression is. So let's move on and understand its type. So there are various kinds of regression like linear regression, logistic regression, polynomial regression and others. But for this session, we'll be focusing on linear and logistic regression. So let's move on and let me tell you what linear regression is and what is logistic regression. And what we'll do is we'll compare both of them. So starting with linear regression. In simple linear regression, we are interested in things like y equal mx plus c. So what we are trying to find is the correlation between x and y variable. This means that every value of x has a corresponding value of y, and if is continuous. In logistic regression, we are not fitting our data to a straight line like linear regression. Instead, what we are doing, we are mapping y versus x to a sigmoid function in logistical regression. What we find out is y1 or 0 for this particular value of x. So thus, we are essentially deciding true or false value for a given value of x. So as a core concept of linear regression, you can say that the data is modeled using a straight line. But in the case of logistic regression, the data is a module using a sigmoid function. The linear regression is used to continuous variable. On the other hand, the logistic regression, it is used with categorical variable. The output or the prediction of a linear regression is a value of a variable. On the other hand, the output of prediction of a logistic regression is the probability of occurrence of the event. Now, how will you check the accuracy and goodness of it? In the case of linear regression, we are various methods like measures by loss, R-square, adjusted R-square, etc. While in the case of logistic regression, we have accuracy, precision, recall, F1 score, which is nothing but the harmonic means of precision and recall. Next is rocker for determining the probability, threshold for classification or the confusion matrix, etc. There are many. So summarizing the difference between linear and logistic regression, you can say that the type of function you are mapping to is the main point of difference between linear and logistic regression. Linear regression maps the continuous x to a continuous y. On the other hand, a logistic regression maps a continuous x to the binary y. So we can use logistic regression to make category or true-false decision from the data. So let's move on ahead. Next is linear regression selection criteria, or you can say when will you use linear regression. So the first is classification and regression capabilities. Regression model predicts a continuous value such as the sales made on a day or predict the temperature of a city. They lie on a polynomial like a straight line to fit a dataset poses a real challenge when it comes towards building a classification capability. Let's imagine that you fit a line between points that you have. Now imagine you add some more data points to it. But in order to fit in, what do you have to do? You have to change your existing model. Maybe you have to change the threshold itself. So this will happen with each new data points you are to the model. Hence, the linear regression is not good for classification models. Next is data quality. Each missing value removes one data point that could optimize the regression. In simple linear regression, the outliers can significantly disrupt the outcome. Just for now, you can know that if you remove outliers, your model will become very good. So this is about data quality. Next is computational complexity. A linear regression is often not computationally expensive as compared to the decision tree or the clustering algorithms. In order to complexity for ant training examples, and x features usually falls in either big O of x squares or bigger of x n. The next is comprehensible and transparent. The linear regression is easily comprehensible and transparent in nature. They can be represented by a simple mathematical notation to anyone and can be understood very easily. So these are some of the criteria based on which you will select the linear regression algorithms. Next is where linear regression is used. The first is evaluating trends and sales estimates. Well, linear regression can be used in business to evaluate trends and make estimates forecast. For example, if a company's sales have increased steadily every month for the past few years, then conducting a linear analysis on the sales data with monthly sales on the y-axis and time on the x-axis, This will give you a line that predicts the upward trends in the cell. After creating the trend line, the company could use the slope of the lines to focus sales in a future months. Next is analyzing the impact of price changes. Well, linear regression can be used to analyze an effect on pricing on consumer behavior. For instance, if a company changes the price of a certain product several times, then it can record the quantity itself for each price level and then perform a linear regression with sold quantity as a dependent variable and price as the independent variable. This would result in a line that depicts the extent to which the customer reduces their consumption of the products as the prices increases. So these results would help us in future pricing decisions. Next is assessment of risk in the financial services and insurance domain. Linear regression can be used to analyze the risk. For example, health insurance companies might conduct a linear regression algorithm. How it can do it? It can do it by plotting the number of claims per customer against its ages, and they might discover that the old customer tends to make more health insurance claims. Well, the result of such analysis might guide important business decisions. So, by now, you have just a rough idea of what a linear regression algorithm is, like and what it does, where it is used, when you should use it rarely. And in the next session, we will learn the algorithms in depth. So don't miss that. And if you have any doubt, you can write down your doubts in our comment section. So thank you so much for watching.